Okay, hello. Can you hear me? I'm going to start the live for today. So, hello, can you hear my voice? Okay, testing the sound. Right. So, this is Junichiro Horikawa, and this is the weekly tutorial live for Houdini, which is called as Algorithmic Live. And this is the 19th episode. I've gone really far, and the topic for today is a procedural flower using a Fibonacci spiral as a base. So it's gonna be really simple and to implement. As you can see, the number of nodes here is pretty small. And what you can do here is you can first of all control the shape of the petal, like these, as well as this one, controlling the side, the cross sections, also from the vertical side. You can also change the total number of petals, radius, or height, like this. And also a scale and what's this? A shape for a flower. The total, like how the petals being placed, can also be controlled with this curve. And finally, the scale ramp parameter, together with the angle inside and angle outside. Combining these, you can create several patterns of flowers like these. Or could be something really interesting, like bowl-like shape or mountain-like shape. It's your choice. So that's what I'm gonna try to do today. And I am not really sure if this is on live, since I don't have any comments here. If anybody is here, let me know. If not, I might have to restart. Let's see. Not really sure if this is on live, but oh well. Hopefully this is, and I am going to just do this. Let me know if you cannot hear or have some problems here, but I'll just continue. Okay, so so the base algorithm of this flower is pretty simple. I'm just gonna use the Fibonacci spiral, which is which is being referred to many other places to create like a array of C's, flowers, and so on. I'm gonna explain briefly what that is about. So you create a bunch of points on, let's say, x-axis. And what I'm gonna do is to rotate this point to clockwise or counterclockwise, either way it's fine, with specific angle for each point. and that angle is the multiplication of a golden ratio, which is 137.5 degrees. So using this angle, you'll be able to rotate the point. So the first point will be rotated 137.5 degrees, and second point will be rotated 2 multiplied by this number. Let's say this is A, and the third point will be rotate 3 times this golden angle, and so on. As a result, what you get as a pattern is more like a seed-like pattern, which is suitable to place like a sun seed or a sunflower seed or flowers or pine cone like surface. And that's all that is in terms of the algorithm. Everything else is more of a control, more of a detail controlling for a petal shape and the final outline of the flower. So that's what I'm gonna do. So because of that, it's pretty easy to implement. So let's see how I do that. So from scratch, I'm going to make this dark, and let's create a geometry node. To start off, I am first going to create this base points for the spiral, so that you'll be able to see how the final things look like without the petal. So first I'm going to create a bunch of points arrayed in spiral shape, then place some fake or pseudo geometries like a circle, and see how it looks like. Then we're going to replace this circle with more detailed petal shape or leaf shape. So let's do this. And in order to create the spiral points, the way I'm gonna do is to use a attribute wrangle with the detail axis, because it's more flexible. I want to add several informations like the normal direction and the up direction, because I want to use this point to be a base for the copy to node. And in order to place the geometry on top of the point with the specific angles, you need to specify the normal direction and the up direction for each point. So that's what I'm gonna do in this wrangle. So let's say I'm gonna name this spiral points, right? And the first thing I'm gonna do is to decide how many points or how many petals that I wanna place. So let's say let's name this number, and let's also create a null node. With an integer parameter. Let's name this petal number from 0 to 1000. Right. And let's see, I'm gonna have this 100, copy this to this parameter. Okay, now I'm gonna create a for loop to create a bunch of points with the spiral angle like I said, using the spiral, Fibonacci spiral angle or golden ratio angle or golden angle. So int from 0 to 100. I want to create a point, or let's start by creating the vector value to determine the position. And let's say I can either create a points on x-axis and rotate it using like a rotation matrix, or I can use the trigonometry to set use the angle to rotate the points. Either way is fine. Maybe for a 2D rotations, I'm gonna use the trigonometry since it's more straightforward. So the angle that I want to use is the radians of 137.5 degrees multiplied by I, which is the number of points, the iteration of the points. Okay, so for each angle, I want to create the x coordinate and y coordinate using trigonometry. That. All right, then let's create a point position using this x value and y value, and let's check how it looks like with this one. But I also need to, in this case, I also need to set the radius. Because right now the radius of this point is always equal to 1, so let's change the radius by just multiplying it by I for now. So the radius will be increased by 1 for each point. Okay, and finally I'm gonna add a new point. To this point and see how it looks like. Okay, so looks good. Looks like the pattern that I wanted to see, and if I increase the point, you see a nice spiral shape start to happen. Okay, looks good. And the spread is pretty much even. A little bit smaller in inward, a little bit larger in outward, but overall it's pretty much the same. Okay, that's good. Now let's reduce this to 150 for now. And the next thing I would like to do is to make this a bit more three-dimensional. Okay, so right now it's being placed on 2D, but I want to make this something more curved or on three-dimensional surface, like a sphere, or other way around, like a ball shape. So in order to do this, what I need to do here is to set the, I guess, the z value here. Right, so let's try to do that. And in order to set the z value, it might be interesting to use the ramp parameter so that you can control the height by yourself, the shape of the height by yourself. So that it could be like any kind of custom shape you want. So let's see how we do that. So in order to do that, what I'm going to do, so So in this case, we need to specify this value here, the y coordinate of this point position. So I could do it after I have created the flat shape. After I have created the flat shape, let's call this, well, maybe it's better we call this z instead of y. And let's create a y value here using a ramp parameter. Now in order to create the ramp parameter, you need to first name the ramp parameter, as well as set a value in between 0 to 1 as an input to output, and output the value which is also in between 0 to 1. So in this case, we can regularize or normalize this I value to in between 0 to 1 by I dividing the I by the total number of I, which is number minus 1.0. So this will give you a value in between 0 to 1 from I. And as a result, you'll get a y coordinate of this ramp parameter. So what you input is the x coordinate of this ramp, and what you get is the y coordinate of this ramp parameter. Now the default value is this linear graph, but we want to change this so that we can control the shape. And after I have got this value, which is in between 0 to 1, we also want to specify the total height, the maximum height of the controlling shape. So let's call this height, like that. And let's make this, let's say, in between 0 to 1, 0 to 10. And as a result, you get this y value, and what you want to do is to change the y coordinate of this position with this value that I have just created. Okay, not sure if something has changed. So this is the C ramp, this is the height. So I think it is changing, but not so much, because the overall radius of this disk is a bit too large, because it's like 125 at here. So let's also try to control the radius so that we can use this height with the regularized radius. So in order to regularize the radius, what we need to do is to control this I value here, where it's being multiplied to the trigonometry point coordinate. So what I'm gonna do is pretty much the same here, just divide this I by the number, subtract by 1, which will give you a value in between 0 to 1 from I, and multiply by some radius value, the final radius value. Okay, which should give you an option to control the maximum radius of this point disk, like that. Okay, much better. As you can see, looks more like a cone shape, which is coming from this graph here. So you can say that the line direction, the cross sections of this part, half of this part, corresponds to this curve. So if I change this, you can see that the curve is changing, in this case creating a bowl-like shape, or in this way you are creating more like a mountain-like shape, like that. So Or you could also do like this to make like a donut-like shape. Anyway, I'm gonna try to make it like a bowl-like shape. Oops. Like that. Like that, yeah. And try to go with this. Maybe it's a bit too high, so I'm gonna reduce the height a little bit and try to go with this one for testing. Now the next thing I would like to do is to try placing some fake petal shape to each of the point to see how we can control the angle. Okay, so what I'm gonna do is to try to create like a fake petal shape using circle for testing. Let's see. So I'm preparing the petal shape. Radius is equal to 1, or maybe radius is equal to 0.5, so the diameter will be equal to 1. Raise up the divisions a little bit, and also place this on XZ plane like this. And let's also place this one of the edge to move this whole circle to either X, Y, or Z direction, or X or Z direction, maybe to the X direction. So by the half number of this radius. Like, no, just the same number of the radius. So moving to somewhere right here. So I want to make this point to be the pivot for the petal for the rotation. Okay, and since this is a circle, it's a bit hard to see like which directions it's being placed when it's being rotated in 2 dimensions. So I'm going to scale the Z direction to make it more like a leaf-like shape. This is just for testing. Okay, and let's connect this here, and let's connect this here to see how it's being placed on top of the point. Okay, so now, right now, the point had, each point is at this point here, and the petal has been placed like this, which doesn't really look like flower-like shape. What we want to do is to rotate these petals more into these directions from the center to those point. So to do that, you need to set the normal direction and the up direction to each point. The most important information is the normal, so let's create the normal direction. The normal direction should be this the direction from the center points to each of the point. So to do that, we can do it right after I have created the points. We can use the function set point attrib 0 and pt with a function to calculate the normal. So the normal should be the current point position, which is this one, minus a center point. In this case, it's 0, 0, 0, so let's just leave it as it is and normalize this to make the length of the vector 1, and try to set the norm. See how it goes. Now it looks like it's other way around. It's being rotated 90 degrees. So what you can do is either rotate the normal or rotate the petal itself by 90 degrees. Maybe rotating this one is much easier. So create or just rotate it by 90 degree here. Not, maybe I should use the transform node. So rotate this 90 degrees. Okay, other way around. Minus 90 degrees. Okay, looks good. Now, there are some problems in this positions, which is because we are still missing one additional information, which is the up vector. So let's also implement that. And the up vector should be perpendicular to the normal direction. And right now the normal direction is not really flat, but it's been placed like diagonally, which has the z value here, or I mean the y value here, the height coordinate. So we should consider that when we are going to create the up vector. So to do that, the first thing I would need in order to create the up vector is to create the tangent vector at this point. So we do have the normal vector value, which is going from this point to this point. But what we need is the tangent vector, which is 90 degree rotated from the normal vectors. And we can use that tangent vector as a axis for the rotation. And after we have got this axis vector, we can use this axis to rotate the normal vector 90 degrees to create the up vector. That's what I'm gonna do. Okay, so first thing first, what I'm gonna do is to create the axis value by rotating this normal direction by 90 degrees. So, and we also need to think about whether we need to project this normal direction to the xy or xz coordinate. Maybe that's better, because since we're just rotating on the flat plane. So let's do that. First of all, I'm going to create the rotational matrix to rotate the normal 90 degrees on xz plane to create the axis vector. Create the identity matrix. Oh, I have a comment, Andres Rug. Cross, right. Yes, using the cross vector is much easier. Thank you for that. So I'm gonna do like that. So I'm going to create the axis by using the cross vector together with the normal with the up vectors, and just in case normalize this because the size might not be equal to 1. Okay, now I should be able to get the axis vector, which is in this direction, which should be in this direction. And now that I have got this, it's time to create the up vector, which is also a cross product between the axis and the normal. So up is normalize cross norm and up normal and axis. And let's try to see it if we got the right value. Okay, let's visualize the up vector value with the vector. Okay, so this is the up vector, which is facing downwards. So let's change the order of the cross product. Okay, so that will give you a perpendicular direction which goes upward. Looks good. Now if I go back to the copy 2 points, the flipping angle should be fixed. Okay, so first step is good, but there are still some problems with this implementation, is because when we do something like a mountain-like shape, something like this kind of shape, you will see some problem here. As you can see, this part looks okay where the point goes upward, but as soon as it reaches to the top, it is still facing like diagonally straight from the center point to these positions, and also have some problems if I raise up the center points like this. Maybe the angle is too steep here, considering the invisible surface, which you should see here, right here. So what I want to have is the angle lying on top of this invisible surface, not like penetrating like these. So they'll be more natural, like it looks more natural, so that the petal looks like it's been placing on top of some kind of a surface. Okay, so in order to do that, we need to rethink how we're going to create this normal direction, the normal and the up vector value. So let's see how we could do that. In order to do that, what we need to have is the gradient of this mountain, actually, right? So I could imagine that if I could get a gradient value from this ramp parameter, then you should be able to calculate the angle for each of the points on the surface. So that's what I assume, and in order to get the gradient from the ramp, this is possible using some Beck's functions, which I don't use that much, but there are some useful ones that I can use for this specific purpose. So let's see. In order to access the C8, the ramp parameter, there's mainly two way. One is the CH ramp, and there's also another information you can get from the ramp, which is called CH ramp deriv, in order to get the derivative. Derivative means you can get the you can get the angle or the steepness of specific point by calculating the small width and small height of specific point. So it's like calculating the tangent value of this angle. Tangent in trigonometry is calculated by width divided by height. So the derivative is that value. So by using that value, you can estimate the angle, meaning you can also estimate the angle for this normal, the petal direction. Okay, so that's what I'm going to try to do. So before creating the normal, first I'm going to calculate the derivative, or get the derivative at specific point, which is using this H ramp, so this one here. So instead of using H ramp, what I'm gonna use is H ramp deriv, using the same parameter for x value. As a result, you get a value which is the calculation of width divided by height divided by width, which is the tangent value. So in order to get the angle from that tangent value, what you can use is let's see, what you can use is float. Let me call this height angle is equal to a tangent, arctangent. By using arctangent for this derivative, you should be able to get the angle on this specific point. On this specific point here or here. Okay, hopefully. And after I got this angle here, let's first check if I have really got the angle or not by setting the attribute just to check. Like this, and checking the point with some markers. Let's give a bigger size here for a text, and it's a bit hard to see in the radians, so let's convert it into degrees to check. Alright, so these are saying minus 74 degrees. This part here is 60 degrees. This part on the top part is close to 0, so looks like we have some promising angles. So what I want to do is to use this angle in order to get the final normal direction, right? So in order to do that, what I'm going to do is to first I am going to just copy the positions to the normal variable and set the y value of the normal to 0 so that it will be flat. It will be on top of the xz direction, right? Xz coordinate, xz plane. Then just in case, normalize this so that the length will be equal to 0, equal to 1. Now that it's flat, it looks like this. Okay, and what we want to do is to rotate this vector by the angle that I have just created, like this one. That's what I would like to do here. And in order to do that, in order to rotate it, we already have this axis for the rotation, so let's do that. The final normal direction. In order to do that, I need to recreate the matrix, the rotational matrix. Where did I do that? I think I didn't do any. Okay, it's the first time using the matrix. So I'm gonna create the rotational matrix, rotate it by the angle that I have created using the axis. Okay, now let's rotate the normal vector value by this matrix. And how does it go? As you can see, it's a bit too small in the length. As you can see, the angle becomes aligning to the invisible surface. Looks like it's aligning to the invisible surface, doesn't it? I think it is. And if I show up the up vector as well, it also looks good. And by placing the circle, looks more like it. Yeah, it's now, the circle is now being arrayed on top of the surface nicely. And if I increase the total number of points, looks pretty clean. And the angle should follow this mountain or the surface that I'm changing using the same system, like that. Yep. The center point has some problem here because there you couldn't assume the direction because it's on the center, so maybe I should remove the points on the center or just start the loop from 1. Yep, should do it. Okay, looks nice. So let's make this shape a little bit nicer, and let's also consider how we're going to scale these petals. I think the scales on the center is a bit too large. Scales on the outer position is a bit too small, so we want to control that as well. And what's this guy doing? Maybe I am missing something here. What if I change this to 0, back to 0? Nope. Let me check. Okay, there are some problem with the up vector value. Also the normal vector, something wrong here. Maybe it's due to some, maybe the point might have gone outside this ramp. It's because of this calculations, I think. Since it's starting from 1, so instead of writing like this, I should write like I minus 1 and divided by the number. Or yeah, do something like this. Same for these. I minus 1, I minus 1 divided by number. Yep. Okay, I think I'm I am missing something here. I need to make this float, or this one to float. Yep. Okay. So this looks good now. So where was I? I need to set the scale for each petals so that we can wait a minute, I have some problem here. Okay, the normal direction is a bit weird. Let's see why. So I have height, position y, I 9.0. Okay, I was missing. So this has been calculated like an integer. So that was the problem. Okay, so this should be good. Now, in order to control, wait a minute. Now I have these things again. Yeah. Yeah, that is because I have subtract by 1 here. Okay, after all, I shouldn't have this. I shouldn't have this after all. Okay. So, what was the topic? So, I need to control the scale. Right. So the scale, let me think about how we can control the scale. Right now, the first thing I could think of is to look at this derivative again. So, and if I change this, maybe not, it's more due to the distance from the center point, I think. So we need to do something with the distance from the center point to control the radius or control the scale of the petal, which is controlled by this coordinate or this calculations, I divided by number multiplied by radius. Okay, which is currently just a linear calculation. Okay, so what we want to do is to somehow control this or use this value to control the change the scale map somehow. So since we are having tons of these calculations everywhere, let's have this as some variable so that we can reuse it. That, like that, and like that. And what I would like to try is to set the pscale to each point so that we can control the scale for the copy 2 point using this f value. Okay, so going back to the where I have created the point, let's try to create the pscale value. Now I guess it should start from 1 to test out, so f plus, I'm gonna start with some simple tryout with this value. So this will be the value in between 1 to 2 based on the distance, based on the point number from the center. So this here will have a scale 1, this here will have a scale somewhere close to 2. And see how it goes. Set point attrib 0 pscale pt with pscale. Looks decent. If I increase this a little bit more, looks decent. So this might be a good solution, but what if I also want to control the spread of the flower? Right now, I'm just using f as it is in order to spread the points. But what if I want to control that as well right here? This f by using some additional ramp parameter, chramp with spread ramp. What if I do that? Meaning if I can control this spread like that. So in this case, there are tons of points on the center. In this case, you have more, how do I say, normalized spread. or you have less points on the center but tons of points on the edge. So you can play around with this spread, how it's being spreaded, or you can make it more like a wavy spread. This looks interesting. It's a bit, looks weird. So in those cases, I still want to I will still want those petals to fill those gaps, to control the filling based on those spread positions. And in those cases, how I should do that? Maybe I could still use the derivative as well as the distance from the center. So shall we try that? Shall we try that? So we have f value, and we also want to calculate the spread derivative using the same ramp for f. Okay, and combining f with this s derivative. And now s derivative could be really, there is a chance that this could be really large because this is the tangent value. So it could be like infinite if you have like high wall shape like these. This could be really high as a derivative value. So we need to regularize it or normalize it to some values that we could use. And to think about how we should use it, let's think about how the value should be used. So where the spread, where the ramp is flat, there is a lot of space right here, and where you have more steep angle, you have small space here, especially those. Or which part are we talking about? Okay, maybe it's not that straightforward to use the derivative after all. Not really sure which part belongs to which in this case. It's pretty hard to determine. It's more like a change, how much it changes, rather than the angle. Right. Well, let's try, and if it doesn't work, I'm just gonna ignore it and just use the f as it is. So same as I did here, I'm going to try to get the angle from this derivative value, which will give you a value in between minus pi to pi, or maybe minus half pi to positive half pi, which is not minus 90 degrees to 90 degrees. So more angle you have, more change you have, and probably that might be equal to more spread you want, or more scale you want to have. So if it's 0, maybe you don't want to have any like scale. I'm just imagining. So in those cases we can reuse this to recalculate the trigonometry, like using sine to this angle. So if the angle is 0, then you get 0. If angle is 90 degrees, then you get value 1 or -1. So let's see, 1 plus sine of s angle, and try to make this absolute so that we always have the positive value. And let's see if it's working by changing. Looks pretty decent, I think. Some interesting glitches are happening in some curves, but overall not bad. Not bad at all. Yeah. Now there are still some spread on the outside, so that can be controlled with the f value, I think. And probably in those cases I could get rid of this one. And looks like we're getting there. Maybe I can multiply this f by some ratio. Yeah. Getting there, but still have some problems here and there. So maybe there isn't that straightforward values in order to fill in the space, but maybe I can parameterize this value and this value to control the scale, maybe. Just a thought. But looks pretty decent. Yeah. I'm not sure if what's the best way to do this, but let's give a try. Let's give those things as a candidate for the parameters. Maybe that's too much, but it's a good tryout. So scale 1 and scale 2 as a parameter. And give them from 0 to 10 and start these by 1. And if it's like a straight line, looks pretty decent. And you can use either value to control the scaling of the petal. Guess not that bad in terms of the how it looks. Okay. So where was I? So the scale looks nice, and final things that I want to try in terms of the placement is the bit more detail angle control. So you might want to like lay these petals customly based on positions and so on. So let's do that as well as a final touch up. Okay, what I mean is to add some additional angle to this rotation here, to this H angle, which is currently just aligning to the surface, but by adding some additional angle like 30 degrees, you can place the petals a little bit upward, or place -30, you can make it flat, and so on. So let's have additional ramp parameter to control the radius, the additional angles to control by setting the minimum and maximum angles together with the ramp parameter. Okay, so float min angle max angle and let's call this additional angle. Float additional angle is equal to chramp f name. I'm gonna name this a ramp for f, which will give you a value in between 0 to 1 again, and multiply by, or use the fit 0 1 to fit between the min angle and the max angle, and use that to this one right here. Since as a parameter I want to use the degrees, I'm gonna convert this back to the radians like this. Okay, so this is the ramp parameter, and I also have this min angle, max angle. Let's have this in between minus 90 degrees to plus 90 degrees, and see how it goes. If I control this here, it changes the angle close to the center based on this linear line, and this one is changing the angle on the outside, again based on this angle curve. But if I change this curve, you can control the angle more dynamically, more customly in detail like that. You have more options to control like that. Getting interesting. Maybe the curve is a bit too steep. Like that, creating some kind of a bowl-like shape. Okay, guess I'm making so many parameters here. Maybe that's pretty much enough. This is a scale. This was the bowl shape, I guess. Alright. Everything is procedural. Okay, so this seems pretty good enough for a placement for the points. Now is the time to replace this petal shape, which is just a circle right now, which is just a ellipse right now. Let's change this to a more rich surface to make it more prettier. And I'm gonna end this live for today. So I am going to start by creating the cross sections of the leaf, of the petal, by starting from the line to the x direction, and let's make the number of points like 50. Like that. And let's try to change the shape, like let's try to create like this kind of arc-like shape to be a half size, the half shape of the one side of the petal. And later we're gonna make the mirror shape to create the final leaf shape. So to do that, I'm going to just use the point wrangle And for each point, I'm going to just move the point to, in this case, z direction. And since maybe it's a good idea to use the ramp parameter again to control the shape, so in order to do that, we need to normalize the point number in between 0 to 1. So f is equal to pt num divided by the number of points minus 1.0, which will give you a value in between 0 to 1. And now I can use this to, with the ramp parameter, to change the shape. The shape that I want is more like an arc-like shape, so let's make it like that. Something like this. And maybe we also want to specify the radius, or how much it goes to the side. So let's give it as width, starting with 1. And then we're going to change the z coordinate with this value that I've just created. Okay, looks a bit too much. Moving too much. So let's reduce it either by controlling the curve here or changing the radius here. Let's make this 0.5 and control the shape. Something like that. Right, like this. Now this is the half of the shape of this leaf or a petal. Next thing I would like to do is to create something more like a contour of the leaf to remake it as a surface. Okay, so to do that, I am going to use the for loop, for each loop, because that's easier. I use the for each number. And specify how many like contours you want to have. More contours have more detail, you can create the surface, but if you make it too big, then it'll be too slow. So let's make it a decent number like 20. Okay, now what I wanted, I know that the final goal is to create the mirrored shape here, right? But in between this shape and this shape, we want to create a tween shape to fill in the gap, so that we can create a loft shape to make one whole shape. So to do that, we can just, inside a for loop, we can just move this smaller and smaller, targeting to the final shape, which is the mirrored shape, and then merge it with this option, merge iteration. And as a result, you should be able to get the contour of the final outline or shape. So to do that, we need to know, we first know the current iteration, the number of iterations, and as always, make the normalized value so that the value you get is in between 0 to 1 for the iterations, which is iteration divided by the number of iterations minus 1. Okay, and then we can use this value in between 0 to 1 as the threshold for the lerp function. Okay, so, and we know that the goal position for each point is this point coordinate multiplied by -1 for a z coordinate. So which is goal position is, we can use the same y, same x, same y, but negative z value. That is the goal, and the current point position is at this point, so we need to, in order to fill in the gaps, we can just use the lerp between the current point position to the goal position using f as a threshold, and replace the current point position with the lerped point position that I get. As a result, you get this nice contour geometry. Now this is currently flat, which is not that interesting, so the next thing I want to do is to make the height, control the height of this leaf, and that's the that's the things that I want to do. And in order to do that, what I could do is, now since I want to make it symmetrical, I mean, it doesn't have to be symmetrical, but if I want to make it symmetrical, then maybe I don't really need to make it symmetrical. Asymmetrical might be also interesting. So let's not consider about the symmetry, but let's try to control the overall shape of this cross sections from the side, which you can do that by using another ramp parameter to define your own shape. Shall we do that? I'm going to use another point wrangle, get the detail informations from the for each count, and what I'm going to do, first of all, get the same value here, get the normalized f value, iteration value, and control the height by using another ramp parameter. So I'm using ramp parameter a lot for this project, which might not be convenient that much. If you have too many ramp parameter, maybe it's a bit hard to control, but you can just remove it, any things you don't really need. Okay, so doing like this and multiply by the maximum height. Should be able to control the total height. Let's make the range from 0 to 10. Right. And what I'm going to do is to update the y value with this h. And where did it go? Okay, now it's a bit too high, obviously. Let's make this smaller. Maybe setting the range from 0 to 1 is good enough. And since I have made this linear, it's going upward, which is not what I really want, obviously. So let's make this arc-like shape by making this like a mountain-like shape. Like that. And we still see some weird, if you look from this side, I don't really like this like square-like shape from this side, so we need to have another shape control for this side, and which means a x coordinate right here. From this side it looks okay, maybe a bit too high, somewhere along here. And maybe if I can have some ridge here, might be nice, like this. Alright, so let's try to control this side as well by adding another ramp parameter. Let's call this I don't know, v. C ramp, b ramp, f. And probably I don't really need to multiply by high because it's already being multiplied right here. Or maybe I can just multiply it right here together with v. And wait a minute. This has to be, this shouldn't coming from f, but it should come from a x coordinate, which is already in between 0 to 1, so that's convenient. I can just use point x coordinate as an input. Okay, now we can control this section with this curve. So let's also make it like an arc-like shape, like that. Interesting. Maybe the other way. Something like this. Looking nice. Maybe higher. Like that. Okay, so I think I'm okay with this contour shape. It's time to create these as a final skin shape by using skin. Nice. If you want more detail, you can just increase this number. Okay, looks nice. Good enough. And that is it for the petal, and we want to replace it with this. Currently, so I can just place this in instead of the circle, and as a result what I get is this whole shape, maybe a bit too detail. Let's also make this smooth shaded or matte cap shaded, and let's try. Thing is, I think I don't want to okay, let me go back to, I don't want to have this point as a starting point, but this point as a starting point, so I think I should go back here and place this sections here instead of here, like that, and also go back to the profile shape and replace this one and this one. Yeah, something like that, and maybe make it a bit thinner, like that. And it's time to control the angle or the number of spread. Okay, let's see what's the best. So we have tons of controls. This is in order to control the layout of the flower. Maybe this kind of shape is good, but the height is a bit too much and the angle is also too much. So let's reduce it, or to the other side, to the other direction. Maybe I need to have in between minus 180 to 180. Yeah, getting nice, getting nice. And I also want to control the scale on the center part, which I should be able to do it somewhere around here or here. It's pretty hard to control. Okay, also getting there. And I think I forgot one thing, which is to control the overall scale value, which I haven't really done. So let's also do that. But what's this? Yeah, this is the spread. Okay, so I think I need actually using derivative might not really make sense after all. Yeah, after all. So instead just gonna use this chramp f value here for the scale, and that's it, together with sc1. Maybe not. It's pretty hard. It's pretty hard, isn't it? Well, didn't really give what I really wanted. Did it? Maybe I might still need this. A little bit better. Oh well, let's say I'm okay with this. Okay, now, so overall it's just about controlling the shape at this point. You can just try out every possible parameters you could think of, and you should be able to create more or less various geometries. using bunch of parameters. This might be good. This might be good. And let's also increase a little bit of numbers. Like that. So that's how I did it, and that's pretty much it, how I created this petal pattern. And I could also change a bunch of material to see how it looks like in different and just changing the matcap per material texture. This is nice. Oh, this is looks more like a leaf rather than a flower, but still looks nice. Okay. I don't really like the opening right here, so let me change it like that. Yeah, doesn't really look like a flower now. Looks more like a kind of a broccoli or something. Okay, well, that's pretty much it. Let me know if you have any comments or feedback. That'll be appreciated. Thanks for all the comments. And as always, I'm going to upload the file to the GitHub and paste the link to the video description page as well as at the Patreon, so please feel free to download and try it by yourself. I'm gonna leave this as it is. And one thing I forgot to do is to promote those parameters that I have set to this controller, so I'm gonna end this live by doing that, after doing that. So first thing, the first set should be to define the shape of the leaf. So let's have this ramp, which is the petal side shape. Okay, and this is the width. Petal side width. Petal side width. What else? Contour. Nothing. This one, yeah, I have two. So one is, this is the cross section shape, petal cross shape 1. Oops. Petal cross horizontal shape. Horizontal shape. Petal cross hori shape. This is the vertical shape. Petal cross vertical shape. Petal cross vertical shape. And we have the height, petal height. Alright, well, that's a lot of parameters. And now these are the shape, and we have now the spiral informations. One is this number of petals, one is this, what was this? The shape of the section of the flower. So flower section shape. And we have the height of the flower section. Flower radius. Even though it didn't really look like a flower, I'm just gonna call this flower. Okay, and we have two types of scale for petal. So petal scale. What was this SC1 based on? Based on the spread. Spread scale. Scale value. And the SC2 is based on the angle derivative. So petal deriv scale. All right. What else? So we have the spread ramp. Now that's a lot of parameters. Maybe this is not that ideal. Spread petal, spread ramp. Okay, and we have the minimum angle and maximum angle for this angle ramp. So angle ramp, and for the maximum, minimum angle and maximum angle. I guess that's pretty much it. And I think I have placed all the possible parameters for this one. Now I should be able to control it through this controller node. So these are all the parameters that I have got. Changing the angle ramp, changing the petal spread. Ooh, this is also interesting. Like it. I think I really like it. Well, this is also interesting as well. And this is a flower section shape. So if you want to make it like a bowl-like shape, you can make it like these. Maybe the height is too high, so reduce the height. Also, for the minimum angle and maximum angle, control it like this. And in those cases, you might want to control the scale as well. So raise up the scale. Like that. these are the leaf, petal shape. This is also interesting. And you can also control the cross sections. You're gonna make it more like a butt-like shape. It's pretty nice. More like a cactus-like profile. Yeah. So this is pretty much it. So you could probably create a lot of variations from this setup, I believe. One thing I could say for this one is that there might be a little bit of modification you might want to do for the scaling part, the petal scaling part, which is not that ideal for now, so maybe there's a place to fix for that. But since I'm doing it on live, I don't have much time to solve this in time, so I'll think about it later. Okay, so this is it. Thank you very much for watching. And as I said, I'm gonna upload these files as soon as I finish this live, so you can check it out to play it. Okay, thank you very much. And if you are interested in this kind of algorithmic process to create shapes, I'm doing Patreon, so it would be great if you could support. And hopefully I'll be able to do another tutorial next week sometime as well with different topic. Okay, thank you very much and good night. All right.